identify your thing from here? Which one?
Warehouse.
Sorry?
Warehouse.
It's here. Okay. Are you ready? Is that part of your presentation time? Okay, hurry. We are still using part of that screen time. But listen, we have something else. You don't have a research assistants.
I know what's working.
Relax, you can start presenting when you reach that part. Go to your side and stage now. So the next you can start presenting, then you reach that part, you connect again. So you are starting at 15, 30.
Okay, good afternoon, everyone that is here. My name is Mugambe KIBIRANGO. Obviously, I'm a student of Makerere University, I'm not sure, near the university, and I'm settled in the physics department. I'm working under the leadership or the supervision of Mr. Benon TWINAMASIKO. Well, our project title was to design and construct an automated coffee drying system. Now we go to the next slide. Well, that is my outline. I'm having only 14 slides. Well, allow me briefly go to the background. Just as I've told you, our project title was designing an automatic or an automated coffee drying system. And as we very well know that in Central here, one of the flourishing economic activity that takes place is coffee farming. And a number of farmers face many challenges, and one of the challenges is the abrupt rains or the rain showers that really bother them. So in this project of ours, so we intended to solve some of those problems. Well, and our area of interest where I based on to carry out this project to solve that problem was Sagas Parish, that is found in Buyukwe district, that is actually adjacent to Mamira Forest. So that is a brief background. Well, I've already gone through part of this, the problem statement, as I've already stated it. I can move on to the next slide, but just as you can see, the lady, well, just imagine that the rains come immediately, like the rains come, and then this lady has to go through all the hassles of covering this rain that you're seeing there. And therefore, in our project here, we saw it wise that we designed an automated system that requires minimal manual intervention, as you are going to see. Well, our main objective was to design and construct this coffee drying system, as you already saw it previously in our proposal that we had. The specific objectives that we have, one is to, of course, construct this automatic coffee drying system, and lastly, after we have designed it, the last specific objective was to test this system. Well, what are some of the significances of this project that you have successfully carried out? One is to reduce on the labor costs. Well, just imagine you're carrying out this farming, and then you have to employ many people. Like if the rains are to come, and then you have to cover the coffee and all that work. But with this automatic drying system of ours, at least we reduce on those costs. And then the other is to reduce the cost losses and improve the coffee quality. Of course, if our coffee is affected by the rains, and then, well, at the end of it, after drying, the quality will not be the same. And lastly is to adopt precision farming. Where the scope, I've already talked about everything here, where our focus was the Sagas parish, and then addressing the challenge of unpredictable rain showers and all that. And the other thing that you need to know that we have Sagas is in the vicinity of Magira forest, and therefore we are bound to remember now this forest also a contributing factor to the rains, and that's the reason as to why we receive the abrupt showers. Go to the literature review, and those are some of the people that have been able to do some work in the same line. But however, now for example, we have RAB, and then the colleagues, they worked on a smart automated solar brain drive. For them, they only focus on the humidity and then only the rain in that system that is designed. But one of the parameters that in our project, and the other parameter that we introduced in is the light or the sunshine. Well, and those others, please. We went through them during the project proposal. Allow me to go to the next slide. These are the materials that we are going to use. One of them is the Arduino. That is as you see it, Arduino, or you can call it a microprocessor. This is where we uploaded our program. So we needed a 12 direct supply power adapter. As you see that part B, we needed a motor drive. Well, I'll talk about everything. Well, we needed the 5DC motor, the LDR, that is the light dependent resistor, and finally down there we have the rain sensor. That is the schematic diagram of our project. There, pointer. Well,
you can use your finger near the projector, you see the finger.
Okay.
Here, you can point from here, you see your finger as a shadow.
Okay. Now, it's like, well, okay. Now, we see this component here. Well, that component there, it is the rain sensor. The rain sensor, we have the rain sensor there. This point here we have the LDR, the light dependent resistor, and then, well, these two sensors bring in a signal to this guy, the Arduino board, the microprocessor. Thank you so much. I want to be like you. We have this microprocessor here is the Arduino. This is where we uploaded our program. This Arduino here gets the signals from the LDR from these two sensors here. The other thing is now, in this project of ours, the system that you are going to come up with, we need to design this structure that is able to open, when the conditions are favorable for the coffee to dry, and then close when the conditions are not suitable for the coffee to dry. And that's why I had to integrate in the motor, this DC motor. But ideally we know that the motor only moves in one direction unless polarity has been changed. And now my task was to program this motor to move in either direction, forward and backward, by using a motor drive. It is this motor drive that I programmed to be able to rotate this motor either forward when it is closing the structure that we intend, whose prototype that we have, and then to move anti-clockwise when the conditions are not favorable. Let me hope that we've been able to get that. So that is our systematic diagram, of course. And the other thing I need to talk about, this motor drive here, this Arduino of ours here, only needed 5 volts for it to run. However, the 5 volts here that are outputted will not be able to run this motor drive because for it requires 12 volts to run. And therefore I needed an external power supply which is the guy here, which is this adapter here, the 12 volts adapter here. I needed it to run my system here. Okay.
5 minutes, so we're moving towards.
Okay, and now the 5, well, we provided the 12 volts, and in turn, it would also give us the, some 5 volts to run the Arduino as well. We have the methods here that I went through where I had to program this Arduino board using the suitable codes that I will not go into details. I used the IDE environment, rather software, to help me do that. Where I had to connect all the sensors, just as I've told you, I've gone through everything there. Well, and the final bit of it was testing and then debugging this system, and then test its efficiency and see whether it is performing the intended actions and duties. Where I go to the results. Well, now someone was wondering how we were able to obtain your data. Well, this program here has a special feature called the serial monitor. The serial monitor helps you to generate the results. Well, because I didn't use any LCD like to display everything. But now the serial monitor helped me to generate this data here that I'm having. Here. At this point there. So we are looking at how our system there will work. I had a column of time, and then the LDR, the results from the LDR column are in basically ohms resistance. And then we have the rain sensor, and then the actions that were going to be performed by, well, the cover, of course, my main emphasis is on the cover. We see that at the start here, this light-dependent sensor, if there is a lot of darkness, now for it interprets it as a higher resistance. Yes? For a higher resistance. And then for the rain sensor as well. Now, for this particular case, we have this column here of the, well, it was the cover action. Initially, the cover was closed. We see that we have for the light-dependent sensor, there is a low resistance, and therefore, if there is a low resistance, that means there is light. And then high resistance for the rain sensor. For the rain sensor, it also literally means that there is no rain, because for this rain sensor here, it has some strips that are separated, and once there is no water, because we know water is an electrolyte and it conducts, you get that here. So if there is no water, there is a very high resistance, and therefore that means those conditions are very favorable. There is enough light and then there is no rain initially. So now our system here will interpret it as a good condition, and therefore the system has to open. And now our system here, like the cover takes 4 seconds to open, and then that means the motor has to run for 4 seconds, and then it does what? It stops. So allow me to stop there, and then I make a demonstration and finish up. So the same trend continues. Okay, the system is under, we are testing to see its efficiency, and therefore, science, you have to be cautious as you're carrying out these tests. Well, alright, now at this particular case, I'm having my light dependent resistor here. The two lights are on, indicating that there is enough light, there is light here, and well, the rain sensor as well. So our system, we are initializing the system. Now, let's assume that there is some darkness. Yes, there is some darkness. So let's assume that now the system is like when the cover is open. Now, there's light, this cover has to move for 4 seconds, and then it stops. Just so it rotated for 4 seconds. Now, assuming that I change the conditions, there is darkness. See, it is moving in the opposite direction. 4 seconds, and then it does what? It stops. Initially, it was moving the other side. So I've changed the conditions. It responds immediately. The response time of this system here, is 2 seconds for it to respond to the changes and then produce an output.
And conclude now.
Right. But I was also going to test for the rain, but you have seen the efficiency of the system. Alright. And therefore, as I conclude here, so this system here that we designed, it is efficient and it really addresses the challenge that is faced by the people in Sagas Parish, and then interpreting the sensors here has given us something very good. So, well,
The recommendation
is very good. The recommendation, I have 2 of them. One is, remember, we need this other parameter that I need to integrate in my system, and it is, we need to regulate the humidity. And for the case of humidity, we worked as a team, and my colleague, Kauma Rashid, will be addressing that challenge, the parameter of the humidity. And lastly, for the future developers, instead of using now sugar depending on the electricity here, the future developers can use batteries or solar panels for this project to work out very well. Well, thank you very much for listening. I wish you good.
Yeah, let's thank that's the presentation. Fortunately, today it is no questions. And we have Mahali.